This next question is question number 4, and it is the last question in the velocity series. And the question reads, calculate the time in seconds an Olympic skier would take to finish a 2.6 kilometer race at an average velocity of 28 meters per second downhill. So we already see right away at the beginning what we're trying to find is time in seconds. So t equals question mark seconds. It gives us 2.6 kilometers and a velocity of 28 meters per second downhill. So we know that our distance equals 2.6 kilometers and our velocity equals 28 meters per second downhill. Now, one thing I want to point out at this moment is when you have units that do not match on your known values. For example, we have kilometers and we have meters. We're not going to be able to cancel those two units because they're not like units. We need to convert kilometers to meters, so then when we get to the plug in the number portion, everything will cancel out. So over here off to the side, I'm going to do this conversion real quick, and it's going to be 2.6 kilometers. And we put kilometers on bottom, meters on top. There are 1,000 meters in 1 kilometer. So it's 2.6 times 1,000, which gives us 2,600 meters. So instead of using the 2.6 kilometers, we're going to use the 2,600 meters. So then meters will cancel and we'll be left with seconds for our time. The equation for this, we'll start off with our original velocity is distance over time. But we need to get time by itself in this problem. So we need to do a little bit of rearranging. I'm going to multiply both sides by time, so that cancels our time on the bottom. And we're not quite done yet because we still want to make sure that we get t by itself, so we need to divide both sides by v. And that cancels our v. We'll clean this up a little bit and we get time equals distance over velocity. So now we just have to plug in our numbers. Time equals, remember we changed our value to 2,600 meters divided by a velocity of 28 meters per second. And to show you how our meters cancel, if you look over here off to the side, if we have meters over meters per second, really what you're looking at is two fractions. You have meters over 1 and meters over seconds. So when you have a fraction divided by a fraction, you multiply by the reciprocal, and you end up getting something that looks like this. The reciprocal of meters over seconds is seconds over meters. So that cancels this out. And then our meters cancel, and we're left with seconds for our answer. And the final answer, when we plug in those numbers, is time equals 93 seconds. That's it. Go back and review it and pause it if you need to. This was a difficult one, but you can do it.